Given the function, state its degree, and if that degree is even or odd. And if the degree is even or odd, does that mean the ends of the graph travel in the same or opposite direction? Talking up or down as we move left and right. And then state if the leading coefficient is positive or negative, and then describe its end behavior. So there's really 4 options, folks. That's it, just 4 options. So let's start with, I mean, you're familiar, I hope, a lot with x squared. The end behavior of x to the 2nd, or x to the 4th, or x to the 6th is exactly the same, the end behavior. Now, if you have x to the 6th or x to the 24th, there's going to probably be some wiggles in between. But in the end, if the left arm goes up, the right arm's going to also go up. So whether it's x squared or x to the 24th or x to the 1/1,000th, those are all even powers. Your end behavior is if the left arm goes up, the right arm goes up. And we know we know that the left arm and the right arm do the same thing. They're both going to go up if they have a positive leading coefficient. So leading coefficient is positive. It's going to be up to the left and up to the right. Now, if we have x squared or x to the 4th or x to the 6th, x to the 24th, some even degree of a polynomial, it's the highest power that you see in the polynomial. If it's a negative out in front, I think of that parabola, the x squared, as being a frowny face. So now the left arm's going to go down, and so is the right arm. You know, again, if it's negative x to the 24th power, there's probably going to be some humps in between, some bumps, but in the end, to the left, if you look at the far left of the polynomial's graph, it's going to be going down. And to the right, the very far right, as x goes to infinity, the right arm will be going down. So even power kind of keeps like the arms, think of the arms of them as arms of the parabola. They're going to be like even, the same. Now if we go odd, it makes kind of a funny dance. Let's think about positive x to the 3rd, x to the 5th, x to the 7th. In my mind, folks, I think of positive x to the 1. That's your y equals mx plus b, but let's take the m out and just make it a plus sign, and a plus over it. If it's a positive x, oh, that looks messy. Shoot. Y equals positive mx plus b, because that number could be anything, but I'm saying that m is positive, folks. That looks like this. That's your hint right there. This is positive x to the 1. Well, it's going to be kind of similar for x to the 3, x to the 7, x to the 19th, x to the any odd degree polynomial. It's going to start, as we go to the left, it's going to go down. And as we go to the right, it's going to go up. That's the slope of a positive line. If your leading coefficient for an odd degreed polynomial is positive, it's going to have this same pattern. Now it's going to be kind of curvy, but as I go to the left, the function will go down. As I go to the right, the function will go up. There might be some humps in between. So if we have an odd coefficient, the ends of the polynomial will do opposite things. If my leading coefficient is positive, it's going to go down into the left, down and left, up and right. All right, now let's look at y equals negative mx plus b. What if m is negative? Well, then there's a slope of a negative line. If we have negative x to the 3rd, or negative x to the 5th, or negative x to the 7th, negative x to the 19th, etc., you see the pattern. It's going to follow this same curve right here is negative x to the 1, because this is x to the 1. So we're going to start up and to the left, or as we go left, it's going to go up. As you go right, it's going to go down. The higher the degree, the more chance there is for some bumps along the way. But that is it. So those are your 4 scenarios, folks. No matter what the power is, if it's an even power for or even degree for that polynomial, it's gotta end like this or like that. The difference being whether the leading coefficient is positive or if the leading coefficient is negative. Well, what if it's an odd power? Then it's either going to look essentially like a positive slope, meaning down and to the left and up and to the right. That's if we have a positive leading coefficient in front of our odd degree. Or it's going to go left and up and right and down. What makes it do that is when we have that odd power but a negative leading coefficient. LC is negative. LC is positive. That's kind of messy, folks. Read through these next 4. I'm not going to actually do 52 through 55, but you should read through them and see if you agree with the explanation given these notes right here.